All right. So let's go through this this homework. The next assignment is up. Again, we're drilling and getting you up to speed on scheme in general, while at the same time slowly inserting some language theory stuff. Last time we were talking about occurs free versus occurs bound, and we'll talk about that some more today as well. So we already are starting to talk about language theory things. It just might be hard to see that as you're drilling this scheme stuff. All right, so let's go through these exercises, and I'm going to walk through these, and so you can kind of see how recursively specified data and solutions to problems kind of sort of work. So this first one, duple, returns a list containing n copies of whatever x is. So again, x can be any element. That could be a list, it can be a single symbol, whatever. Today we're going to learn that it actually could have been a function. Okay, today something we're going to talk about is that functions are first class variables in scheme, which means if we wrote a function, we can actually pass it as a parameter into another function. Okay, so we'll see that before class is over today because you'll need that for your assignment tonight. All right, so duple takes in an element x and a number of times we're going to repeat it, and it should return a list containing that number of times, right? Okay, well, so again, scheme does not officially support loops. Therefore, when we're recursively specifying data, one of our magic tricks needs to be recursively calling a function over and over and over again and counting down a number. Okay, so we're going to first define, what's it called, duple. Okay, duple is going to be a lambda procedure that's going to take in two parameters, an n and an x. N is number of times, x is the element. Then we're going to ask the question if n is equal to 0, if we are not supposed to duplicate again. Okay, if we've counted n down from 5 to 4 to 3 to 2 to 1, whatever, if we're done, we're going to go ahead and return the empty list. And the reason we're returning the empty list is because more than likely what we're about to do here is we're about to start constructing a list, right? We're going to be consing x onto whatever's returned by calling duple on n minus 1 and whatever x originally was. So cons requires that the final element be a list. So we need to have list built up to list, built up to list, otherwise cons breaks. All right, so when all is said and done, what we're not going to call recursively again, we're going to boil down to the empty list here, which finishes off our final cons. So if n is equal to 0, we're done. Otherwise, the else here is we're going to cons what? Cons x, the element, onto whatever duple returns, passing it n minus 1 and x. That make sense?
So you just kind of like go through each element here.
Sure. So first of all, let's see it work. Okay. So let's go ahead and let's do duple for a. That gets us a list with 4 a's in it, right? Okay, so it does seemingly what it's supposed to do. And for those of you who maybe saw some funny syntaxes, what was it, haha, that one? Something like that. Notice it gives us this weird syntax like this. What this is, it's saying, I'm going to treat any place where I have -1 dash as actually being equal to this. So this was their shorthand, that -1 dash here is a placeholder for this guy. That makes sense? It's kind of like so things don't get too scary, even though it looks scary right off the bat. Okay, so actually that's correct output. You could just replace each one of these with the list haha, and then you'll see it's actually correct. All right, so let's walk through and see what this thing does for A. Okay, we saw that it gives us the right answer, but let's kind of walk through and see how it actually builds out. Okay, so very first time we call duple, we're passing in a 4 for n and an a for x. First question we ask, Is n equal to 0? Is 4 equal to 0? It's not. Therefore, we come to this part of it, okay? And what do we say to do there? I'm just going to kind of write it out down below here. We're going to cons an a, which is the value of x, onto whatever's returned by duple passing it a n minus 1, which is a 3, and an a. That make sense? Okay, so that's our first recursive call to duple. Since n was not equal to 0, n started off as being equal to 4, we're going to jump over the true expression and go to the false, so the else. And we're going to return the cons of whatever x is, which in our case is a, onto whatever's returned by the function duple when applied to the inputs of n minus 1, which is 3, and the same x as we had before. Okay, so now we're at this call right here. We have to wait for that guy to get returned. Okay, so this is the call to duple with a 3 and an a. Is 3 equal to 0? Nope. So we're going to return the cons of a onto the duple of 2 and a. Counting down, n minus 1. Okay, again, some people are getting stuck on this thing. Remember, in Scheme, every single function is stored inside of a list where the very first element is the function name. So the function we're calling is the minus function. The two parameters are n and 1, and this will subtract 1 from n, producing a final result. Make sense? All right, so we're going to call duple of 2 and a. So now we're on that call. Is 2 equal to 0? It's not, so duple 2 to a will be equal to cons of a onto the duple of 1a. Now we're on the duple of 1a. Is 1 equal to 0? It's not. So we're going to cons a onto the duple of 0a. Is 0 equal to 0? It is. So we boil down to the empty list. So this guy ultimately boils down to the empty list, which means that this guy right here actually boils down to the empty list, which means that this guy right here actually boils down to the list containing a, which means that this guy right here actually boils down to the list containing a, which means that this guy right here actually boils down to the list containing 2 a's, which means that this guy right here actually boils down to the list containing 2 a's, which means that this guy right here boils down to the list containing 3 a's, which means that this guy right here boils down to the list containing 3 a's, which means that this guy right here boils down to the list containing 4 a's, which is our final answer for duple of 4a. Does that make sense how that kind of unpeels? So we just keep going down, 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 down until we finally hit a 0, and then we bounce back up because each one of these is this was a promise of getting an answer. This was a promise of getting an answer. We had to wait for that answer, though. Go ahead.
So you were saying in the if statement that if that is always going to be false, and you go down to the con statement. Well, what if you switched it? If it was greater than 0,
Yeah.
if cons was always, if it was always true, you would construct that, and if it was false,
Yeah, that's
that would
fine.
still work.
Yeah, I mean, it worked the same. Just the alternate. So if it's equal to 0, return the empty list. Otherwise, do this. Otherwise, you could say if n is greater than 0, do the cons. Otherwise, return the empty list. That one Well, they both, I guess, assume that you're counting down. So it's fine. They're equivalents. All right, questions on duple. So we see, even in a simple one like this, where we're just doing something 4 times, we see how much complexity is actually built into the recursion there, right? This idea of the recursive solutions, recursive specified data. All right, so that's duple. What was the next one? Invert, where LST is a list of 2 lists, so guaranteed that each list has a length of 2. That's what your book refers to as 2 lists. It should return a list with each 2 lists reversed. Okay? So, for example, if I pass it this list, the list containing these 4 2 lists, the 2 list A1, the 2 list A2, the 2 list 1B, and the 2 list 2B, it should return a list containing the first 2 lists inverted. Instead of A1, it's 1A. The second 2 list inverted, instead of A2, it's 2A. Third one, instead of 1B, it's B1. And the fourth one, instead of 2B, it's B2. All right, so we need to start off by figuring out how do we invert a 2 list. Okay, so we're going to do this in a couple of little pieces. If you remember from class last time, I could scroll up a little bit here if you want to, but I'm a little bit lazy right now. But we had this little thing in the book that said something about breaking problems down into their individual little steps. Remember that from last class? All right, so one approach you should take when you do these homework assignments is don't try to solve the whole problem. Try to solve parts of the problem and then put those together into one big solution. All right, so for this one, what I'm going to start off doing is I'm going to forget about the giant list. And I'm just going to say, if I was given a 2 list, how would I invert a 2 list? That's it. Okay, so I want to write a little function called, I don't know, we'll call it invert for right now, and then we'll just rename it. Swap? Okay, we'll call it swap. Fair enough. So we're going to write a function called swap, and swap's going to take in a 2 list. All right, and all it should do is produce a brand new list that is the original 2 list with the elements reversed, using only what we've learned in here so far. Okay? So I'll leave duple up there so you can reference it later. So I'll say define swap to be a lambda. That's going to take in a single list as a parameter. And in our case, we're guaranteeing it will be a 2 list. All right? So out of curiosity, if I have a 2 list, how do I access, if LST is any 2 lists in the world, how do I access the very first element of that 2 list? And how do I access the second element of that 2 list? What's the first element of that 2 list? The car. And what's the second element of that 2 list? Car of the cooter. The cooter will be the second element as a list, right? Because the cooter takes the rest of a list except for the first element and returns it as a list. So if I want that second element as an element, I need to take the car of the cooter. All right, so as an example here, if I have the list A1, the car of that is A. The cooter of that is the list 1. The car of the cooter is the value 1. Make sense? All right, so the car of the cooter or the catter. The catter gets you that second element as well. All right, so I want to produce a brand new list, and I know some of you asked on Slack whether or not you had access to the list function or not. Sure, you can have access to the list function, but I'll actually just do this with cons, same diff, right? And then we'll do it with the list just so it's clear to everybody. So I need to construct a list where the first element of the list should be the second element of the first list, of the original list, and the second element of it should be the first element of the list. And remember, the rules of cons say that you ultimately need to be building this onto the empty list. So I'm going to return the cons of the catter of LST onto the cons of the car of LST onto the empty list. like that. So if I were to say swap A1, I get 1A. And I'll go ahead and write this the other way with the list. I'll call this swap 2. Swap 2. I'll just get rid of that. So we're going to create the list of the car of of the catter of LST and the car of LST. We'll call this swap 2. Does that make sense? So the list function creates a list out of all the elements you provide as parameters. Or if you want to pretend like that doesn't exist, you can construct your own list using cons. So we can build our own list function if we wanted to. So what am I doing here? I'm consing this element, the catter of the list, onto whatever's returned by the function cons when consing the car of the list onto the empty list. So this guy right here will ultimately boil down to a list containing the first element. And I'm consing onto that list the second element, producing a new list. Make sense? So I don't care which of these solutions you go with, but the punchline here is as you looked at this problem, solve this portion of the problem first. How do I take a to list and invert it? Make sense? All right, so any questions on swap or swap 2? Do we have a preference on which one we like better? In this particular case, now that you have the list function available to you, I would say this one is probably the cleaner solution. Because one thing you do want to do is you don't want to confuse things too much with a whole bunch of recursive calls to things if you don't need to. We're going to be confused enough as it is for right now. So I'm going to call this version of swap our good version of swap, the one that uses list, even though we saw that they're functionally equivalent.
One question: did you have to do the empty list on the other one? Because doesn't cons, like if it's just two things, like two values or two symbols like that, it creates a list pair automatically.
So I'm going to cons that element onto that element like that. Let's call that swap. Let me keep this called swap 2. Must be a list. It's the second element. Okay, so it's a requirement of cons. Second parameter must be a list. Okay, so now I have a nice function called swap that will that will take a to list and swap it, producing a new to list, right? All right, so now I'm supposed to write a function called invert. And invert is going to be a lambda. Let me press enter here. It's going to be a lambda that takes just a list as a parameter, and this list is going to be a list of two lists, correct? Okay, now what do I want to do? I want to go through every element of that list. So we're looking for what's our stock way of traversing every element of a list and doing something to each element. So I need to keep looking at the cars of this list and calling swap on that car and then consing the results of swap onto it over and over and over again until I finally end with an empty list. And an empty list implies that there is no car. Make sense? If I have the empty list, taking the car of it is illegal. I'll get screamed at. All right, so inside here, I'm going to ask the if statement. So if, a couple different ways we can ask this. How do I ask if it's the empty list?
Null question.
Okay, null question mark. So this says if the list is null, then I'm going to return the empty list. Pretty much the same thing as we did above. That's going to be the end of my cons, okay, if it's null. Otherwise, what am I going to do? I'm going to cons whatever's returned by swap on the car of our list onto calling invert on the cooter of our list. All right, and let's test this here. So we have invert, we have a list, and what is it? The list A1. Actually, do I need to put I don't think I need to put the quotes in there. A1, A2, 1B, 2B. Is that at least fairly close to the... Make sense? Okay, so let's walk through this one. So this one actually, after we see the answer, looks very, very, very similar to the original one in terms of structure, right? Forget about swap for a second. Just compare invert to duple. Aren't the structures of those two fairly similar to each other? But this one does something much more scary. And that's where we start getting screwed up, right? The second we start getting intimidated by what it's doing, instead of just letting it do what it does, and we're going to do it to every element. I'm going to show you a really cool shortcut here in a second. But let's walk through it as it stands right now. So if I'm calling invert on this list of two lists, the first thing we're going to do is we're going to ask, is LST, this is LST the first time through, right? Is that the empty list? It's not. Not even close. All right? So what are we going to do? Since it's not the empty list, we're going to cons the result of swap on the first part. And we know that swap will do what to this? Swap and return as a two list, right? So we know the result of swap will be the list 1A. Are we okay with that? Or do we need to go and throw swap, do follow swap? Okay, we can trust that swap does what it's supposed to do. So we're going to cons 1A, the result of swap, onto calling invert on everything but the first element. Okay, so now I've called invert on a list containing 3 two lists instead of a list containing 4 two lists. But the good news is I've already swapped the very first guy. So then we ask, is this the empty list? So we need to get the answer of this guy right here. Is that the empty list? It's not. So what are we going to return? We're going to return the cons of 2A onto a call to invert, passing it the list 1B and 2B. Then we have to ask, is this version of LST equal to the empty list? It's not. So what do? We cons swap of the first element, which will be the list B1, onto calling invert on the rest, which would be the list containing the list 2B. So now we're calling this guy. Is this the empty list? It's not. So we're going to cons the result of calling swap on the car of that list. The car of that list will be the 2 list 2B. Swapping that will be the 2 list B2 onto a call to invert on the cooter of that list, which is the empty list. Finally, this ends our recursion. Is this the empty list? Yes, it is. And what do we do when it's the empty list? We boil down to the empty list. No more recursive calls, which means we can now replace this guy with the empty list, which means that this guy becomes the list containing the list B2. Okay? So that's what this guy is, which means that this guy will boil down to the list containing the list B1, B2. Which means that this guy will boil down into the list 2A, B1, B2. Which means that this guy will boil down to the list 1A, 2A, B1, B2. Make sense? Go ahead. Why? Why would you do this to us?
Just question about like list, empty lists, and null. Like in Java, you can have a list that's not null; it's just empty. Whereas in this, you're talking like it's both. You know,
If you use the null predicate, what's a predicate, by the way?
the boils down to true or false.
Yeah, any function that'll boil down to true or false. Good. So if you use the null predicate, in Scheme, most predicates have a little question mark at the end. It's naming convention in Scheme, not a rule, but a naming convention. When you use that on a list, it will return true if it's the empty list and false otherwise. That's what that predicate does for lists. If you call null on another type of variable, it'll return true if it's nothingness and false otherwise. So it really has more to do with, it's not a Java versus Scheme thing, it's really what does the null question mark function do? Okay, so I think your thought process for it is correct, that it does something different depending on the type of value you send to it. You can also use the length. I've introduced length of a list, right? So another way of doing it, you could ask, we could ask the question, equal length LST 0. That's equivalent to saying null LST, if its length is 0, or there are 0 elements in that list. Make sense? All right, so you want the cool trick now? And you might want to remember this trick because it may help you greatly in your next assignment. So we already wrote swap, right? So I'm going to write invert 2, define invert 2 to be a lambda that takes LST, takes a list in there, and I'm going to map swap onto LST. So I'll call invert 2. So there's my same answer. But this is the entire invert function. So remember at the beginning of class today, I mentioned that functions are first class objects, first class variables in Scheme, which means I can actually pass a function as a parameter to another function. So our map function here takes 2 parameters. It takes a function. It takes a function that takes a single input. Let's leave it at that for right now. So map takes two parameters, a function that takes a single input and a list. And what it does is it applies that single input function to every single element of the list. Okay? So as an example here, let's say that I had the, let me do define a list to be 1, 2, 3, 4. So just a list of numbers. All right. Now, what I can do is I can say map lambda x times xx onto a list. What will the output of this be? Give you a hint.
Everything multiplied by itself.
Everything multiplied by itself. So basically squaring everything. What's this guy right here? What kind of animal is that? Lambda function. What's a lambda? What's the definition of a lambda? Unnamed function. Just because it doesn't have a name doesn't mean that it's not still a function. So this is a function that takes in a single parameter, and what does it do? It multiplies that parameter by itself. That's what this unnamed function does. And what am I going to do with that unnamed function? I'm going to apply it to every element of a list. So I'm going to apply it to 1. So it'll return 1 times 1. I'll apply it to 2. Return 2 times 2. 3 times 3. 4 times 4. Make sense?
What if you did like made 2, 3 a list? So it's 1 and then the list 2, 3 and then 4.
Well, so tell me, what happens if I multiply the list 2, 3 by the list 2, 3?
That's just right.
Okay. So he wants to make this a list. But what does that actually say? It says that the multiplication function does not operate on lists. It knows how to do math stuff. So lists aren't numbers, therefore we can't do math stuff with them. Which is good, because that would have made actually one of the problems for your homework assignment easier. I think you have one on the Cartesian product, if I remember correctly. That just sounds scary.
Is there a way to put comments in?
It's a semicolon. Semicolon at the beginning of the line.
Anywhere on the line.
Oh, I think.
Yeah. So this is equivalent to // in Java. All right. So that map function will come in handy. In fact, just so we don't forget, let's go ahead and add it to our toolbox just so I don't get any whiners later on saying, oh, you never introduced that to me. So we have the map function, takes a function and a list and produces a list, let's say takes a one input function and a list and produces a list with that function applied to every element. Make sense what map does? So map maps a function across a list. That's its job. Hey Pebbles, how did the homework go, by the way?
Phenomenal.
Did it? Are you saying that like you didn't do it, did you? How did the homework go? Phenomenal. You didn't do it, did you? Did you ask for help?
I actually just got
Didn't you have like a week to do that assignment? 5 days. That's like a week.
Pretty close.
Actually, for college students, 1 day is like a week. Because even though I give you 3 weeks, you're going to wait till the day before and then do it.
Don't judge me.
So much stuff to do all the time. Because our
There's
Well,
papers and.
shouldn't this be? I mean, you're in college. It's like a full-time job. You should be
I'm supposed to
spending.
be doing nothing but drinking and partying. That's what.
It's like, look, I agree to write a check for $25,000 per year, and I expect to be able to drink and party. Why are you crimping my style with homework? Oh, we're on the same page now. I get it.
You can join.
Ay. What was I doing? Oh, we're still working on your homework assignment.
Drinking and partying.
We're drinking and partying. All right. So does invert make sense? All right. So now next one, down. This wraps parentheses around each top level element of a list. Okay, now we've already written a function that goes through every element of a list, right? That's that structure of continue to call recursively until it's the empty list, until the cdr is an empty list. How do I wrap something in a list? Go ahead. Okay, concatenate it with an empty list. Cons it onto the empty list. Is that how it works? Cons a list onto the empty list, and I get a list containing that list. Yeah, if I cons an element onto the empty list, I get a list containing that element. Whatever kind of animal that element was. If the element was a list, it'll be a list containing a list. If the element was a list containing a list containing a list, it'll be a list containing a list containing a list containing a list. Nailed it. All right. So just to keep consistent with what we did in the previous one, because I want you to solve the mini problems first, okay? So what I'm going to do is we're going to write a little function here called wrap. Here, I'll leave the map example on there. Let me just, I'll comment it out just for right now. Okay, so we're going to write a little function, define wrap to be a lambda that takes in a list as a parameter. Actually, let's have it take in an element as a parameter. And what is it going to do to the element? We're going to cons it onto the empty list. Alternatively, we could have created a list out of the element, right? Use the list function. So I can either cons it onto the empty list, or I can write the exact same thing here. We'll call this guy wrap2, where I actually just call list on that guy. Make sense? So which of these do we like better? Second one, they're equivalent. Second one maybe looks a little cleaner. I want to make something a list. Well, I pass it to the list function. All right, but they ultimately have the same output. So if we call wrap2 on an A, we'll get the list A.
Isn't that just equivalent to calling the list function?
It absolutely is.
So why do we
I'm doing it the identical way to what we did in the previous one with the swap.
Okay.
Swap and invert, we're doing wrap, and then our equivalent of invert. But you're right, because I could actually just map list onto this thing, and all of a sudden that assignment became a lot easier, right?
Yes.
But you didn't have access to map for that one. All right. So there's my wrap A. If I want to make it a list containing an A, and call this, then I'll get the list containing the list A. Make sense? So now my job is to go through a list and take every element of that list and wrap it. Isn't that what we're supposed to do? Okay. So what am I going to do here? What was the name of this? Down. Okay. So we're going to define down to be a lambda. And this guy's going to take a list as a parameter. And I want to go through every element of that list. So if null, LST, then what am I going to do? I'm going to return the empty list. Else, what am I going to do? I'm going to cons whatever's returned by wrap on the car of LST onto down on the cooter of LST. Now the important thing to see here is that what we just wrote here is almost identical in structure to what we wrote for invert. Take a list, go through every element of the list until we no longer have elements, do something to each element. And what are we doing to each element here? We're wrapping it as opposed to, so what do we call it? Swapping it as opposed to swapping it up here.
But is that the same thing as actually putting parentheses around it? We're just making a, what we're doing is making a list. We're not actually putting parentheses around it.
Sure we are. Right here. I passed it the list A, and now it's the list A. There's parentheses around it. This is how it represents. So this guy right here, this list A, that's equivalent to that. That's how the console represents what I just typed. Look at the screen first before you answer. Those two things are equivalent to each other. So scheme just happens to represent it with this list thing to let you know that this guy is actually a list and not like a weird input into something. Its structure, its bone structure is that of a list. All right, so now go ahead and ask.
I just thought the problem was that we were supposed to like insert like just any kind of character into the list, not just like
Any kind of character into the list. What do you mean?
it could be like a U or a 7. It could be anything, not just like parentheses. You know, if it wasn't parentheses, how would we do something like a bracket or something?
The way the problem states it, it sounds like you're not trying it. The end result is yours looks like it's parentheses around it, but all it is just a list. You didn't actually put parentheses around it. Like if it had said wrap 7s around every element.
Oh, okay, I get it.
Then you wouldn't be able to use the list function. You'd be able to use what you did because that would just make it a list, not.
Okay. So how would you solve this then?
Well, that's what
I did do that, and then as I was getting down to it, I realized it would be a lot easier to just do the lists.
Okay.
Just
So really what you're saying is the question is worded funny.
Yes.
Okay. Wrap parentheses around each top level, as opposed to saying make each top level element a list.
But the thing is, though, the function only takes in one thing, which is a list, so you wouldn't know what you want to wrap it around.
Well,
If it was a wrap it around.
but say
something
they
else.
changed it to 7 or a Q or something, then
Yeah,
I did it. I had it, except I could only get it where I couldn't use parentheses. I didn't know how to make it do the parentheses. It didn't like that because it would just think it was starting another function or something.
Mm-hmm.
So I did like a quote, and then I could get quotes to appear around all this stuff.
If you change the language, it would do that, though.
Yeah, see the problem.
But then it still is.
Yeah, the problem is you can match it to the output, but since there's spaces here, not that they couldn't have worded it. I'm not necessarily arguing they couldn't have worded it better. But since there are spaces here, it seems relatively clear that this is all one element as opposed to.
Yeah, I see what you mean. Yeah.
So. But it seems like based on what you guys knew how to do, you really had to do it the way I just did it. Or something very similar to that. But I do get that this one was worded funny. But I think you either had to not solve it or do it the way I did it. One of the two. So this is down. So then of course what we could have done is we could have just mapped wrap onto LST. So if we define down 2, for example, this will be a lambda that takes in an LST, and all we would do is map wrap onto LST. But then, as you pointed out, we could actually just map list onto LST and get rid of both of these things. So that's actually the entire solution to that question with map. Make sense? You didn't have access to map again, but just reiterating how map works. All right, but this was the intended solution. Something like this, which should look very similar to invert, original invert. So that's our structure for going through every element of a list and doing something to each element. All right, questions on that one? All right. Next one. 18. Swapper returns a list. Returns a list, the same as S-list, but with all occurrences of S1 replaced by S2, and all occurrences of S2 replaced by S1. Okay, so again, we're going to be going through every element of S-list, but let's look at what's the nature of S-list here. So we got to look at our different inputs here. So we have a list containing A, B, C, D. That's one example of S-list. Another example of S-list is a list containing A, D, empty list, C, D. Another example of S-list is the list containing the list containing X, the list containing, or then just a Y, then the list containing Z as well as the list X. All right, so we have a list of symbols, or in this case an S-list, is a list of symbols or a list containing lists of symbols. Make sense? So we need to be aware of that as we write this solution. So the first thing we want to do is we want to take an S-list. And so we're going to solve this in little tiny passes. So we're going to take a list, like this very first one, A, B, C, D. And we're going to walk through this list one element at a time. Okay, again, we're thinking about this in terms of elements, one element at a time. And we're going to ask ourselves, does this element match? Does this element match A? Is that what it's called? S1. Does this element match S1? If it matches S1, then what are we going to do? We're going to cons on S2. What if it matches S2? We're going to cons on S1. What if it doesn't match either? We're going to cons on the element. But what if the element is a list? So we're going to deal with this in the flat list thing first. We're going to assume that our input always looks like this. Does not contain other lists. Okay? Version 1 of this will be S-list is always a flat list of symbols. Does not contain other lists. So we're going to write that structure. Define swapper to be a lambda that takes in two symbols, S1, S2, as well as an S-list. Then we're going to ask if null S-list, then return the empty list. Otherwise, if. So if I'm in this if, I know that S-list has a car. So if, we looked at a couple of different ways of testing elements, right? The equal sign is for testing numbers. We're looking at symbols, so I need to use EQ question mark. So if S1 is equivalent to the car of S-list, if that's a true statement, what am I going to do? I'm going to cons S2 onto swapper of S1, S2, and the cooter of S-list. Else, I'm going to cons S1 onto swapper. Actually, I need to do in this else, I need to ask another if statement. If EQ question mark S2 is the car of S-list. So if S1 matches the car of S-list, then I'm going to cons S2 onto whatever is returned by swapper on the rest of the list. If the car is equal to S2, then I'm going to cons on S1 onto the whatever's returned by swapper of S1, S2, and the cooter of S-list. Otherwise, it didn't match either of them, so what am I going to do? I'm going to cons the car of S-list onto whatever's returned by swapper of S1, S2, and the cooter of S-list. Okay, so same structures we had before. Keep going through our list until we have the empty list, in which case we're going to return the empty list. Otherwise, we're going to do something with the current element. Okay, we know there's at least one element on this guy if it's not null. So we know we can look at the car of S-list and get an element. Notice that I keep really driving home this idea that it's called an element. Okay, take notice of that. You'll be a lot less confused when you do your homework. All right. So I'm asking if the element in the car of the list is the same as S1. If they're the same, then I'm swapping S2 out for that guy. So I'll cons S2 onto whatever's returned by swapper, passing it. Oh, this is just, why didn't somebody stop me? There we go. Then I'm consing S2 onto whatever's returned by swapper when applied to these three parameters. S1, S2, same two parameters before, and then the rest of our S list. Okay, we're only going to do that if S1 matches the car of S list. That's when we swap it with S2. Otherwise, now we're down here to the else part of this, if S2 matches the car of S list, if that's a true statement, then what am I going to do? I'm going to cons S1 onto, I did it again here, people. Testing you and you just suck. Okay, so cons S1 onto whatever's returned by swapper, passing it the same S1, S2, as well as the cooter of S list. Huh? All right, good. Okay. Else, if I'm here, if I'm still kicking right here, that means that the car was not S1, the car was not S2, therefore I'm going to keep whatever the car was and just cons it onto swapper for the rest of the list. Make sense? All right, so this is version 1 of our swapper. So what's the test sequence? AD and then ABCD. So we'll call swapper on A, D, and then A, B, C, D. And we get the list DBCA. Is that what we're supposed to get? All right, so far so good. Pass test 1. Now we go back in and we look at test 2. A little scarier. AD, and then it's AD list CD. AD list CD. DB list CA. DB list CA. Still kicking. Then XY list. The list X, Y, the list Z. Okay, I'm going to have to go back and forth a couple times here to write this right. So this is XY. I think it comes in funny.
You just have to change each of the.
Yeah. This is better practice for me anyways. Actually, I could probably just not use the single quotes, right?
Yeah.
There's that, and then there's that. Okay. So this guy should have been replaced with the Y, right? But didn't get replaced with the Y. It should have gotten replaced, right? Okay. So this guy should have gotten replaced, but he didn't. This guy should have gotten replaced, and it did. This guy should not have gotten replaced. This guy should have gotten replaced, but didn't. So we have an issue. The issue is that I only, well, really the issue comes down to this last part right here. What do I do if the cars does not match S1 or S2? I can't necessarily just cons on the car of S list, because the car of S list may be in and of itself an S list. And what do I do with S lists? I call swapper on them. Okay, so how do I detect if this guy is an S list? Okay, I could do another if statement. And how do I ask the question? Are you an S list? Let's look at our toolbox here and see what we have access to. Okay, we have symbol. As far as what you know how to do right now, the only way I know it's not a the only way I know that it's a S list is that if it's not a symbol, right?
You could also check to see if that the car of what you just took there, and see if that is a symbol, and then just if it is a symbol. If it's not a symbol, then you know it's a list.
Yeah, exactly. Yeah. So there actually is another predicate called list. Yeah, so we actually, I'll just go ahead and add it to our toolbox here. We do have another predicate here called list that returns true if something is a list, false otherwise, but we didn't have access to it here, so we won't use it. So I need to have another if here. So I'm going to say if symbol car of S list, if the first element is a symbol, then what am I going to do with it? I'm just going to cons it on to the swapper. Do what we did before, but only if it's a symbol. If it's not a symbol, then what am I going to do? I'm going to cons swapper S1, S2 onto the car of S list with whatever's returned by swapper of S1, S2 onto the cooter of S list. Perfect. Made my font too big. All right. So if the car of the S list is a symbol, we're just going to keep it, cons it onto whatever's returned by swapper for the rest of it. Otherwise, I'm going to cons on whatever swapper returns for this first element, which is an S list, along with whatever swapper returns for the rest. Let's see. I have parentheses problems. All right, so that's good there. What do we do here? Stop.
That has opening where the pink is, opening parentheses, opening parentheses.
Oh, same mistake I've been making? That one? So now we have the list Y, the X, the list Z, and the list Y. So now it seems to be appropriately dealing with it. And it should now go deeper and deeper. If we have S lists inside of S lists inside of S lists, we'll keep catching up.
Will that work with
What was the number 2 example again?
Oh, the one that just had the parenthesis in it, or just had the list, the empty list.
No, was there one of them that used integer?
It didn't have one that used integers. Number 2 had the empty list here. So we would have called swapper on that. Seeing that it was an empty list, it would just return the empty list. Not tried to do any magic. None of them use integers. All symbols.
It wouldn't work though. It
It wouldn't work if they were integers because we say symbol. If you want this to work for integers, we would have to say symbol and number. If it's neither of the, if it's a symbol, do this. If it's a number, do this. Otherwise, treat it as an S list. Make sense? Okay. So important thing to look at this one. Was that our 2-star or 1-star still? 1-star. Okay, yeah, that's why it was easy. All right.
The 2-star was the easy one.
Just teasing you.
Yeah, that honestly was probably.
Okay. So now, as we look at this, shut up. This one was obviously more complex looking, right? Obviously more complex looking, but the structure is identical to the structure of the other 2. We did the exact same thing. We went through, keep whittling down our list, and we did something to every element of the list. The one thing we did on this one is we said, if the element is a certain kind of animal, we need to treat it differently than we treat symbols. If it's a list, we actually need to recursively check that guy. If it's not a list, that is, in our case, if it's a symbol, deal with it. Make sense? All right, so this one would have been a very important question to solve, taking into account those little baby steps. So one thing I want you guys to pay attention to, and maybe go back for entertainment purposes and watch the way I solve these problems. When I say stuff out loud, notice that I'm saying one little step at a time, the next little baby step to solve. That's what's going on in my mind when I'm problem solving these. One little tiny thing at a time. What do I do if it's a symbol? Well, if it's a symbol, I need to see if it matches the symbol that we're checking for. If it does, do this. If it doesn't, do this. And let your solution kind of grow. All right, so that's swapper. Next one is list set. LST_NNX returns a list like LST, so whatever list we pass in, except that the nth element using zero-based indexing is X. So we're essentially replacing the nth element. Is that what it's doing? Is it replacing it? List set. Here's our list A, B, C, D. We're saying make position 2 a 1, 2. So this is 0, 1, 2. Does C still exist in our last one? It does not. So it's replacing that element with it, right? As opposed to just making bucket 2 that new element. Because you could have read this a couple of ways. You could have said, we'll keep the C, but bucket 2 now becomes the list 1, 2, and C just maybe becomes bucket 3. Something like that. List ref A, B, C, D, bucket 3, 1, 5.
Just solve for the top one, hope the second one works.
Well, no, this is just calling list ref on whatever's returned by list set. Say give me number 3, which should show that this guy's the new bucket 3. It's just proving that it did.
I don't know. I just solved for the first one.
Yeah.
Hope
Yeah.
the second one
Well,
works.
but no, just understand what the second one's doing. Here's the problem that it's passing. This guy right here. That's the test for list set. Remember we introduced the function list ref last time that allows us to get a certain element of a list? Okay, so for instance, today when we did our, what was it, swap or something like that, we could have said list ref 0, list ref 1 to get the first and second element instead of the car and the catter. We could have done that. Well, this is to prove the point, since this is the element we're putting at bucket 3. So that's what list set says. It says make bucket 3 this guy. when this guy boils down to the solution list, we're calling list ref on bucket 3 and making sure it matches this. Kind of a stupid way to show the example, maybe a confusing way, but that's what they're doing. All right, so it seems clear from this that what they're having us do is replace whatever's at bucket X with the second element, right?
Really, well, no.
They don't even give us an indication of what we should do in the event that there is no bucket X. So I guess we're assuming that there's a bucket X, or yeah, is it bucket N? That if there's not a bucket N, what do we do? So I guess we just assume the list is has that many things in it. So we're going to define list set. We're going to go through every element of our list. Right? Go through every element of our list until we get to the element defined by N. So if I say, if N is 2, I need to keep consing the car of my list on over and over and over again and whittling down N until N is finally equal to 0. Then I know I'm in the right place. That make sense? But then I still need to keep subtracting 1 from it. I need to keep subtracting 1 from it and calling it again, because the place that we're replacing may not be the end. It might be somewhere in the middle. And we only want it to be equal to 0 one time. All right, so solution to this one should be list set, LSTNX. Define list set to be a lambda LSTNX. Is that how the parameters are supposed to go? List set LSTNX. Good. All right. So we'll do our if. If null LST, return the empty list. So our kind of our usual as we're going through every element of the list. If it's not that, then we need to ask the question. If N is equal to 0. If I'm looking at N is 0, then what I'm going to do is I'm going to cons X onto list set of LST minus N1. And I want the cooter of LST, right? So the rest of the list with N minus 1 and X, even though we're never going to use X again. So that's just kind of keeping it going. So that's if N is equal to 0. Otherwise,
You just take X and the cooter of list.
are we guaranteed that the rest of it is, it doesn't matter how deep
Doesn't
the,
matter, right.
yeah, this will work too. But yeah, you're right. You're right. Let's just kind of keep going with it, just so we match up. But you are right. Yours would be better. So cons, what are we going to do? We're going to cons the car of LST onto list set of cooter LST, again, minus N1 and X. All right, so list set is going to take in a list, an element we're replacing, and the element we're replacing it with. If we finally run out of things in our list, and again, we're assuming that element N does exist, then we're going to return the empty list. Otherwise, if N is equal to 0, if we've counted down to that point, then we're going to go ahead and cons our replacement onto whatever list set returns for the rest of the list, N minus 1 and X. If it's not equal to 0, then we're going to cons the car of the list, keep what was already there, onto list set of the cooter of the list, N minus 1 and X. All right, so, and then the test here was this guy. I just need to fix my single quotes, you said? Actually, it looks like they came in maybe okay. Nope, they didn't. So list A, B, 1, 2, D. What it's supposed to do. Okay, and then what he suggested is if I did have it equal to 0, rather than consing x onto this stuff, I could actually cons it onto the cooter of LST, because I know I found my spot and I'm done. So this saves potentially a lot of recursive calls, depending on how early in your list the place you were swapping out was. All right, that one makes sense? So same structure as we had before, except we kind of had to figure out a way to stall in the middle. The way I solved it first, while substantially less efficient than what he suggested, literally matches what we've done before, where we just keep counting down, keep subtracting 1, but we only actually stop and do something special when it was equal to 0. His takes into consideration that we've actually done what we tried to do, so let's just grab the rest and move on with life. Better solution, but doesn't exactly match our structure that we've been doing up to this point. So if you're looking for paint by number, my solution is probably the one that's closer to paint by number. His is the one that's more correct. Okay, so that was 119. Finally, 120. This is the last one, the assignment. Right? The next, we still got 2 minutes, right? All right, count occurrences. S in S list returns the number of occurrences of S in S list. Okay, so what we're going to have to do is we're going to have a way of counting. So I'm going to have a count for an S list that's going to go through every element of the S list, looking for how many times something occurs. So let's write that real quick. So I'm going to do define, it's a race, count to be a lambda that takes in an LST and a val and a, let's see, yeah, we'll say val and a num. And what this guy is going to do is he's going to say if null LST boil down to 0. So same structure, but instead of going down the line of whittling down a list, I'm actually going to add a number each time through. So this will be my endpoint where I did not find a copy of val inside of LST. Otherwise, if car of LST is equivalent to val, if I found a match, then return 1 plus count of cooter, LST along with val. Actually, I don't need this num. This num's stupid. With val, and yeah, like that. Else, just call count of cooter LST val. So count should boil down to the number of times val exists in LST. Problem here is, and we'll have to just look at it at the beginning of next class, but the problem here is I have to look at how deep this allows it to go. Because you can have lists inside of lists inside of lists potentially. So I do have to look at if the car was a list, I need to call count on that to get my full count. But ultimately what I'm doing is the same pattern. I'm going to count how many times something is in a single S list, add them all together, and ultimately spit out a final result. Make sense? So same thing we've been doing. So homework for next class is 121 through 125. Remember, you have access to map. Also notice these guys are all 2 stars. So I would start yesterday.
When are we going to get to the 3 stars?
Yeah, huh? I posted first thing this morning. But you should have started yesterday. Right after that I posted.
You should have just known.